So the first thing I like to say is, what is computational science? You know, when we started 25 years ago, every time I mention we're starting a program in computational science, people ask, what is computational science? And I have to go and give a long explanation about it. At that time, nowadays, you do a search, computational science, you get millions of things, okay? But at that time, I struggled trying to convey what I mean by computational science, till one day I came up with a way to explain it. I said, to me, computational science is an evolution of applied mathematics, where you take aspects of computer science and then you work in solving problems in science, engineering, and in general. The truth is that if you go across the country and you go to every math department and you ask what is applied mathematics, you will get many, many different versions, but nobody questions the existence of applied mathematics. Today, nobody questions computational science as a discipline. Okay? So here we got 4 paradigms of science. Used to be a tripod, but we have empirical science, theoretical science, and now we have computational science and data-driven science. At the end, actually, it's the same, because when we do computational and data science, we're actually dealing with data. And nowadays, we have a humongous amount of data, and I don't know, maybe 10 years ago, people were complaining that they didn't have enough data. Right? So, but the CSRC was established in 1999, but in paper, and then in 2000, we started the center, and in 2002, we started a PhD program, and we actually have traveled quite a bit in this journey, which is well written, I guess, we'll label in our newsletter, which is the Odyssey, because we have done a tremendous journey through this time. Basically, we offer PhD and master degree and in the interdisciplinary setting. And this is something that is important for me to emphasize, because there are even today many places where people talk about interdisciplinary research and they don't really talk to each other. So that's here is true that we actually foster and do cooperation among the disciplines. And the mission from the beginning was to promote the development of computational interdisciplinary research across the university. We have not been very successful, but we even have interaction with people even from the music department and the arts, so which is something that it will come. So the CSRC facilitates interaction among different, an array of scientists, engineers, mathematicians, statisticians across the university. And we also believe, like the profile for our students is that our students have to be able to identify we have developed a computational infrastructure that sustain our research. So we have contributed to the mission of the CSU and the SDSU. So we actually participate in many projects, international, national, and across the university. We also started the computational infrastructure for research at San Diego State University, and still today is the main component that our students and faculty have access to. So this is just a brief chart about the CSRC, where we got 3 associate directors, and unfortunately we had 2 vacancies that we haven't been able to fill, not because but due to the budget problems that are persisting in the state of California. So, but hopefully this is something that will be improved over the years. And we also have 60 or 58 faculty of research associated with the center. So we do partnerships with the lab, national lab, industry, and basically also we do interaction with industry through the advisory board and through this program, because this program basically is outreach to interaction with industry. The Access program basically was designed for that purpose, because we want our students to have the experience to work in real world problems. And usually those problems come from industry and national laboratory. So that's the best way for us to really tackle problems of that magnitude. And we do have interaction with industry over the years in different levels. Okay? Now, we also do, part of this is establishing partnerships. Okay? And we have many partners over the years, and we have done different projects. Nowadays, these are three that we are in the process of, let's say, finalizing. Or one is the Naval Information Warfare Center, and the other one is XTEM-E, which is actually a startup company in Palo Alto, who is specializing the theme of the keynote, which is computational health. And General Atomics, which is local, and we have a grant now for building capacity at San Diego State for fusion plasma research, and our partner is General Atomics and is funded by the Department of Energy. Our approach is multidisciplinary and interdisciplinary training. So we actually, this is a concept that we came up a long time ago, and we have used for a proposal. We call something called discovery teams, that then you have faculty from different areas, postdocs, PhD students, undergrads, assembling a team to tackle a particular project. And we put a lot of proposals in that way. So the basic skill set that we actually get a student to have is to be able to work in team projects. And you have to be able to lead a team and also be part of a team without being the leader. But it's a rotation that you learn to be in different parts of the projects. They are interdisciplinary. Software, and I basically described our students have to be tool makers as much as tool users, because most of the problems today that are important, are interesting, they cannot be solved with standard software. So you actually have to develop new tools. Planning, you have to be able to plan and accordingly so that you achieve your goals in a reasonable amount of time. And communication is something that is key, because you have to be able to convey what you're trying to say to a specialist, somebody in any setting, funding agencies, any level. You will see some of that in the Blitz. There are students will line up starting from that part, and each one will come and say 1 minute, they will say something about the research and invite you to go and see their posters. So this is basically what we have over the years. As the Vice Provost mentioned, we actually contribute 10% of the PhDs graduated towards the classification of the university to BR1. So that's a decent amount, and we hope to increase that over the years. This is actually, forgot to update this, but it's actually certainly way more than 300 publications in peer-reviewed journals. This is from our students. These are some data, which is also some of these need to be updated because there are people moved from different places. But we do have alumni in national labs, Microsoft Research, supercomputing centers, industry, and academia. And one that I actually like to mention, because I was told once that it was no way that one of our alumni will have a tenure track position in the math department. And we now have a faculty, well, it's an alumni who, after doing a postdoc in the Chancellor Fellowship at UCSD, is now a tenure track faculty at UC Irvine in the math department. Funding, well, we already heard this, but we also contribute substantially towards the research enterprise university. And in the last 5 years, this is actually a decent amount, and we keep increasing more and more. And one thing that I want to convey that besides this, we also are interested in having industry fellowships. Because, for example, the industry is a way for the industry to invest into the program, is providing a fellowship that will help to recruit more and more students for this. Okay, like I said, ACSESS is an industry interaction, outreach to industry. We have the industry immersion seminar, which is something that we started recently, and it's actually been very well received by the students and the speakers. We do have the poster session that you will have the opportunity to see the students. And a lot of our students go to national lab for summer internships, some go to companies, but it's also something that we actually foster, and they get a very good experience. As I said, this is basically the goal of ACSESS. It's a benefit for industry, benefit for us. And in summary, we're training the next generation of computational scientists for the 21st century, and we need your help to make it that way. Thank you.
Thank you, Dr. Castillo.
Oh, I forgot, actually, this one. Right now, we are in the process of grading our research network. So we started a long time ago with what is called the DMZ, where we have a research network dedicated just for research. And it was 100 gigabits per second. In this summer, in partnership with the IT division, we actually are going to be the first university in the United States. We have 800 gigabits per second.
Again, thank you, Dr. Castillo. All of Computational Sciences Research Center, CSRC, is driven by your vision and your hard work. So